Hey everyone, and welcome back to the Deep Dive. Today we're diving into something that sounds like it's straight out of a spy movie or science fiction.
Invisibility.
You got it? Camouflage, cloaking, the whole shebang. We're talking about the chemistry behind how things disappear.
It's amazing, isn't it, how nature has been doing this for millions of years.
It really is, and the science behind it all is incredible.
Absolutely.
So we've got 5 fascinating factoids lined up for you today.
Okay, I'm ready.
First up, we'll talk about chromatophores, which are like little pigment sacs that cephalopods use to change color.
Ah, the masters of disguise in the ocean.
Exactly. Then we'll move on to polymer camouflage.
That sounds like something straight out of a lab.
It is. Scientists are basically trying to create artificial skin that can change color and texture, just like in nature.
Wow.
Then we'll dive into adaptive optics, which is all about controlling how light interacts with objects.
So not just matching colors, but actually bending light to make things disappear.
You got it. And then, of course, we have to talk about invisibility cloaks.
Like Harry Potter.
Well, not quite robes and magic, but the science behind it is pretty mind-blowing. We're talking metamaterials and bending light around objects.
Sounds complicated.
It is, but we'll break it down for you. And finally, we'll touch on stealth coatings, which are already being used on aircraft.
Right, to make them invisible to radar.
Exactly. So, are you ready to explore the chemistry of disappearing acts?
Absolutely, let's dive in.
Okay, let's start with those masters of disguise. We were talking about cephalopods like octopuses and squid. They use chromatophores to basically become chameleons of the sea.
They're really incredible creatures.
I know, I've seen videos of octopuses changing color in the blink of an eye, but how does that actually work? It can't just be a bunch of paint bags under their skin, right?
You're right, it's way more sophisticated than that. Think of chromatophores as tiny, elastic sacs filled with pigment.
Okay.
Each sac is surrounded by muscles, and when those muscles contract, they stretch the sac, making the color more visible.
So it's like having thousands of tiny, controllable dots of color all over their bodies.
Exactly, and they can mix and match these dots to create all sorts of different patterns.
So it's not just about having different colors, it's also how those colors are displayed and combined.
That's it. And here's where it gets even more fascinating. The nervous system of these cephalopods actually controls the muscles around the chromatophores.
You mean their color changes aren't random?
Nope, not at all. Their brains are controlling the whole show, and the changes can be triggered by all sorts of things, their surroundings, their mood, even the presence of a predator.
Wow, so they're not just changing color, they're processing information and reacting to their environment in a super complex way.
Exactly. And some species even have different types of chromatophores, some that reflect light, others that absorb it, creating an even wider range of colors and patterns.
That's so cool.
Oh, and the speed at which they can change is just mind-blowing, like milliseconds.
So it's not just camouflage, it's almost like an instant visual communication system.
You got it. Now humans are trying to catch up with nature a little bit. We're developing what's called polymer camouflage.
Right, I read about this in one of the articles. So is this basically like trying to create artificial skin that can change color and texture?
That's the idea. Scientists are experimenting with different types of polymers that can respond to different stimuli, like light, temperature, even pressure.
Oh, wow.
And these polymers can do some pretty cool things. They can change color, become more opaque or transparent, and even alter their texture to blend in with different surfaces.
So instead of just having a static camouflage pattern, like on a traditional uniform, this could adapt to the environment in real time.
Exactly. Imagine soldiers wearing uniforms that can seamlessly blend in with a forest, a desert, even an urban environment. And it's not just for the military. Think search and rescue teams, wildlife photographers, maybe even fashion designers.
That's wild. Okay, so we've got natural camouflage with chromatophores, human-made camouflage with polymers. What about adaptive optics? I'm still a bit fuzzy on how that fits into this whole invisibility thing.
Adaptive optics takes camouflage to a whole other level because it considers how light interacts with objects. It's not just about matching the color and texture of the surroundings, it's about controlling how light reflects and refracts to make an object blend in even more effectively.
So you're saying it's about making something invisible regardless of the lighting conditions.
That's the ultimate goal. Every material has what's called a refractive index, which basically measures how much it bends light.
Okay.
And adaptive optics uses materials that can actually change their refractive index in response to different light conditions.
Okay, so how do they actually do that? Change the refractive index, I mean.
Well, one promising approach is to use polymers that respond to electrical signals. By applying a voltage to the polymer, you can alter its molecular structure.
And that changes its refractive index.
Exactly. It's like turning a dial to adjust how much the material bends light. And by matching the refractive index of the surrounding environment, well, theoretically, you could make something disappear.
So it's like, turning a dial to adjust how much the material bends light. And by matching the refractive index of the surrounding environment, you could theoretically make something disappear.
Precisely. It's a fascinating area of research. We're not quite at the invisible man stage yet, but the potential is there.
This is mind-blowing. Okay, let's move on to something that sounds even more like science fiction. Invisibility cloaks. Are we talking like full-on Harry Potter-style invisibility here?
Not quite robes and wands just yet, but the science behind it is fascinating. It's all about bending light around an object.
So it doesn't actually disappear.
Nope, the light just goes around it, making it invisible to anyone looking at it.
So how do you bend light like that? I mean, is that even possible?
It is with metamaterials.
Okay, metamaterials.
They're not something you find in nature, though. They're artificially engineered materials, and they have this unique ability to manipulate light, in ways we never could before.
So what makes them so special? What makes them different from regular materials?
Well, think about it this way. A material's properties come from its structure, right?
Right.
Metamaterials, they have a very specific structure,
Okay.
often at a microscopic level,
Okay.
that's designed to interact with light in a very particular way. It's kind of like building a tiny, intricate maze that guides light waves around an object. And that's what makes the object invisible.
So it's not that the object disappears, it's more like the light is tricked into going around it.
Exactly. Think of it like a stream flowing around a rock. The water doesn't disappear, it just changes direction. And so you can't see the rock anymore. Metamaterials do the same thing, but with light waves.
That's pretty incredible. But you mentioned earlier that invisibility cloaks aren't quite perfect yet. So what are the limitations? What are scientists still working on?
Well, for one, most invisibility cloaks only work for a very narrow range of wavelengths.
Meaning?
They might make an object invisible to certain colors of light, but not to others.
Okay.
And then a lot of them only work from specific viewing angles, too.
So you might be invisible from the front, but not from the side.
Yeah, exactly. There are definitely still some kinks to work out.
Makes sense.
Another big challenge is size and flexibility. Creating a large, flexible cloak that could work for all wavelengths of light, that's still a big hurdle.
So we're still a ways off from having, like, Harry Potter-style invisibility cloaks, then.
Yeah, that's true. But the progress in this field has been amazing.
It really has.
And the potential applications go way beyond just making things disappear,
Yeah, like what?
Metamaterials could revolutionize optics, telecommunications, even energy harvesting. There's so much potential there.
That's pretty amazing. Okay, let's come back down to Earth for a minute. Let's talk about something that's actually being used right now. Stealth coatings on military aircraft.
Ah, yes. Stealth technology. A real-world example of chemistry at work.
So how does that work exactly? Is it similar to invisibility cloaks?
They're actually quite different. Invisibility cloaks try to bend light, but stealth coatings work by absorbing radar waves.
So it's not about making the plane invisible to the naked eye, but rather invisible to radar.
Precisely. They use special materials that absorb those radar waves instead of reflecting them back.
So that makes the aircraft harder to detect.
Exactly. Much harder.
I bet the composition of those coatings is top secret, huh?
Oh, absolutely. The exact formulas are closely guarded secrets, but the basic principle is using materials, often containing carbon, that just suck up those radar waves.
So it's like a sponge soaking up water, but instead of water, it's radar waves.
Perfect analogy. And just like a sponge can only hold so much water, different stealth coatings have varying levels of effectiveness.
I see.
The shape of the aircraft also plays a big role. A sleek design can really help minimize those radar reflections.
So it's a combination of materials, science, and engineering.
Absolutely. It's a great example of how chemistry and design work together to make incredible things happen.
It's just fascinating how we've gone from, mimicking the camouflage of cephalopods to manipulating light with these metamaterials and absorbing radar waves with specialized coatings. The possibilities for achieving invisibility in all its forms seem almost endless.
And that's just the tip of the iceberg. There are tons of researchers out there exploring all sorts of different approaches to invisibility, from using lasers to even manipulating sound waves.
Wow, so the future of invisibility is going to be even wilder than what we can imagine today.
I think so. The quest to figure out invisibility is far from over, and who knows what amazing discoveries are still waiting for us.
Before we move on, though, I wanted to touch on something a bit different, something that might be considered invisible in a different sense. We've been talking about visual invisibility, but what about chemical camouflage? Things that are hiding in plain sight, so to speak.
Oh, I see where you're going with this.
And sometimes this kind of invisibility can have some pretty serious implications for our health.
You're talking about ketene, right?
Exactly.
That hidden toxin they found in some synthetic cannabinoid products.
That's right. It's the perfect example of how something can seem harmless on the surface, but actually be hiding dangers that are really hard to detect.
And this really highlights how important it is to understand the chemistry behind the things we're using, especially when it comes to products that are marketed as natural or safe.
Correct.
Just because something comes from a plant, it doesn't automatically mean it's safe, especially when we start talking about synthetically modified compounds.
Exactly. And in the case of ketene, it's formed when certain synthetic cannabinoids are heated like when people are vaping.
Right.
So they're unknowingly inhaling this highly toxic gas.
And it can be really dangerous. Ketene is super reactive and can cause some serious damage to your lungs and respiratory system. And there's still a lot we don't know about the long-term effects.
That's a little scary.
It is.
It's a good reminder that knowledge is power, especially when it comes to our health. We need to be informed consumers and understand what we're putting into our bodies.
Absolutely. You have to do your research, be aware of the ingredients, know the potential risks before you use any product, especially ones that have synthetic compounds in them.
That's why deep dives like this are so important,
I agree.
They can shed light on those hidden dangers and really empower us to make informed decisions about our health.
Knowledge is the best defense we have. We've got to stay informed and be vigilant.
Okay, so we've explored this fascinating world of invisibility, from natural camouflage to cutting-edge technology. And we've also talked about the importance of being aware of hidden dangers, things that might be invisible to the naked eye.
Yeah.
So what's the key takeaway from all of this?
I think the big takeaway is that science is always pushing the boundaries of what's possible, and sometimes that reveals amazing wonders, and sometimes it uncovers potential risks. We've seen how curiosity and, that desire to understand the world can lead to incredible breakthroughs, but it's also important to remember that every discovery comes with a responsibility, right? We have to use that knowledge wisely and ethically.
It really makes you think, about how much we've learned about the world around us and how much we still have to discover. It's not just about making things disappear. It's about understanding how we see the world and then, using that knowledge to create these incredible possibilities.
Exactly.
And speaking of possibilities, there's one more area of research I wanted to touch on before we wrap up. It might seem like kind of a leap from, all this invisibility stuff, but
Oh, what is it?
it's also about like pushing the boundaries of science and unlocking these secrets that could really change things for a lot of people.
I'm intrigued. What are you thinking of?
Research into male contraception.
Oh, wow.
It's amazing, right? For so long, the responsibility for contraception has mostly fallen on women. But now, with all these breakthroughs in male reproductive biology, it seems like things are starting to shift.
Yeah, it's a really exciting field. It shows how science is constantly evolving, leading to these innovations that could change how we live and interact with the world. And it's about time, honestly.
Right. For years, the research into male contraceptives has been focused on these hormonal approaches, but there were often a lot of side effects, and they weren't always that reliable.
Yeah,
I've heard about those hormonal methods, but they haven't exactly caught on.
right.
So what's different about this new research? What makes it so promising?
Well, a lot of the latest research is looking at a non-hormonal approach.
Interesting.
They're focusing on a specific receptor that plays a key role in how sperm moves.
A receptor. Wait, so instead of messing with hormones, they're targeting the mechanics of sperm movement.
Exactly. This receptor, it's called P2X1, and it's basically essential for sperm to, swim effectively. So scientists are trying to develop drugs that can block this receptor.
Oh, okay.
And they think this could lead to a really safe, effective, and reversible male contraceptive.
So it's kind of like putting a temporary brake on sperm, stopping them from reaching the egg.
Yeah, that's a great way to put it. And since it's not messing with hormones, it's likely to have fewer side effects. And hopefully, that'll make it more appealing to men who might be hesitant about those hormonal options.
It's amazing to think that we might be on the edge of such a big shift in reproductive health.
I know, it's exciting.
It really shows the power of science and why it's so important to keep investing in research.
Absolutely. It's just one example of how science is always pushing forward, leading to discoveries that can make our lives better and really change how we see the world.
Okay, so we've covered so much ground today, from the chemistry behind camouflage to the physics of invisibility cloaks, the hidden dangers in seemingly harmless products, and now the future of male contraception. What's the big picture here? What ties all of this together?
I think the message is the power of scientific exploration and the importance of using our knowledge responsibly. We've seen how curiosity and the desire to understand the world can lead to these incredible innovations, but we also have to consider the ethical implications. Every discovery comes with a responsibility to make sure it's being used for the good of everyone.
It's a reminder that science isn't just about, cold, hard facts and discoveries. It's about understanding the implications and making informed choices.
Exactly. And as we keep learning more about the universe and pushing those boundaries, it's crucial that we do so with a sense of responsibility, always looking for ways to use our knowledge for good.
Well said. It's been an incredible journey exploring the science of invisibility and beyond. Thanks for joining us on this deep dive. We hope you learned something new, maybe even found something to explore further on your own.
It was a pleasure talking about all this with you. Remember, the world's full of amazing things just waiting to be discovered, so keep that curiosity alive and never stop exploring.
And on that note, we'll leave you with one final thought. If we can already make objects invisible to radar and bend light to make things disappear, imagine what else is possible. The possibilities are truly endless. And it's up to all of us to shape the future of science and technology, to make sure it benefits all of us, and the planet. Until next time, keep diving deep. 669.